we would like to find what is this integral, and as far as you can see, there is the arctangent function, which is the inverse function of the tangent of x. I proceed to do this example because usually most of the people who are newcomers, they are not familiar with inverse functions, inverse trigonometric functions. Almost everyone knows the trigonometric functions, but few people are familiar with computing this kind of integrals with inverse functions like this function, the arctangent of x. So we don't know how to go back and find the antiderivative of this function, so we need to find the function which the derivative gives this arctangent of x, which is not a trivial thing to do. So we might consider other ways to tackle this problem. So one can think of application of integration by parts. Let's see how we can write this. Let's consider this expression here. So we write this integral. This integral is equal to the integral of x prime, which is the derivative with respect to x. This derivative is equal to 1, so we go back to this integral. Therefore, we can do integration by parts. It will be x times arctangent of x times arctangent of x minus the integral x times the derivative of arctangent of x dx. The derivative of this is, so I can write it here properly, the derivative of arctangent of x is 1 over 1 plus x squared. Now here we only have this integral to evaluate. And how do we do that? We multiply and divide by 2, so we will have 1 over 2 integral 2x over 1 plus x squared dx. Of course, one could do the substitution and introduce a new variable in the integral, but we don't want to do that here, just for the sake of simplicity. So you notice that the derivative of the denominator is the numerator, so you can notice this pattern here, that the derivative of the denominator is the numerator, so the derivative of x squared plus 1 is 2x. Of course, now here you have to be a little bit careful. What is the derivative of natural logarithm of x? Is 1 over x. But now we have the derivative of a function. The derivative of a function is 1 over f prime of x, 1 over f of x times f prime of x. Therefore, here this integral is the natural logarithm of x squared plus 1. Consequently, I is a function of x, and it is given by this formula, x times arctangent of x minus 1 over 2 times natural logarithm x squared plus 1. I really believe that if you are not very familiar with the tactics, then you might get lost somewhere, but you can work out this problem and see how it works and become more comfortable with such an integral. Thank you for paying attention to my video and for devoting time to my videos, And until the next video, I hope that you are enjoying yourself.